Hi all, welcome to Sangalp Learning Classes. In this session, we are going to discuss 5 mark questions from the chapter Relations and Functions. We have already discussed the multiple choice questions and 3 mark questions. So we'll be straight going to discuss the topics that are needed in the uh, needed for 5 mark questions. That is mainly they ask questions from inverse of function and composition of function, mainly inverse, and then you have to know the concepts of one and on two functions, right? So these are the main points that you should study for the 5 mark questions. Okay, so we'll be straight going to the new topics, that is we haven't discussed about composition of functions as well as inverse of function, right? So we'll have a quick reflection on what is composition of function and what is inverse of a function. All right. So in this, we have to first discuss what is composition of functions. So the composition of functions f from a to b, that and g from b to c. So you are given two functions, okay? That is f and g are two functions, and the f is defined from set a to set b. Similarly, g is defined from the same set b, okay? The codomain of the function b to c. All right. So we'll get a function g composition of. Okay, G composition of is F, and that will be defined from set A to C. This is known as composition of the functions G and F. What is it? G composition of F. And what will be its domain? Its domain will be A, and its codomain will be C. All right. So, and it is defined by G composition f of x is equal to G of f of x for every x element of A. So this one I'll explain it with help of an example. All right. So I'm considering two functions, f from R to R. Similarly, g from R to R. R means the set of real numbers. All right. So we have to find out f composition f. For that we need f, right? So let f of x be the function cos x, and g of x be the function x 3x square. All right, 3x square. Now you have to find out f composition g and g composition f. Okay, you are going to find out a different function, and what is that function? It is nothing but the composition of the given function. So f composition of g will be defined as f of g of x, f of g of x. All right, then how will you find out this one? This is nothing but f of what is g of x? What is g of x? It is given, right? 3x square. So f of 3x square. All right, f of 3x square, that is equal to. Now what you will do? Here you are defining a function f of x, but in the place of x you can see another function. What is that function? 3x square, which means you know the function f of x. What is that function? Cos x, but the variable is not x. Here the variable is x, so the function is also in x. Here you can see that instead of the variable it is another function. It is 3x square. So you have to replace 3x square with x. Okay, that is cos x will become cos of 3x square. In the place of x, there is another function, that is 3x square. So this is f composition g. Now you have to find out g composition f. How will you find out g of f of x? G of f of x. It is nothing but g of what is f of x? It is already defined. It is cos x, right? G of cos x. And now you have to check what is g of x. G of x is 3x square. G of x is 3x square. So you replace this x with the function given in the bracket. What is it? Cos x. So it will become 3 into cos x the whole square. Cos x the whole square can be written as cos square x, right? 3 cos square x. All right. So these are f composition g and g composition f. I hope it is clear to you. Now we'll have a quick reflection on what is inverse of a function. All right. Inverse of a function. Let's discuss the other way, that is using arrow diagram. We'll discuss what is inverse of a function. All right. So actually, if you are given a function, let it be a function from a to b. Okay, a to b. Now, what will be the domain and codomain of f inverse? Okay, that is a notation, right? The function inverse of a function f means nothing but f inverse. This is the notation. So how will you, what will be the domain and codomain of this particular function? It is inverse, right? We are discussing about the inverse of a function. So if f is from A to B, you think it as a reverse process. Okay. Inverse is nothing but the reverse. It is, we are finding out the reverse of that function. All right. So f inverse will be defined from B to A. Okay. Sorry for the interruption. So F inverse is defined from B to A. All right. So I'll explain it with the help of an arrow diagram. So let this be set A and this be set B. All right. So the set A contains the elements 1, 2, 3 and B contains the elements 4, 5, 6. All right. So I'm going to define a function such that 1 is mapping to 4, 2 is mapping to 5, and 3 is mapping to 6. All right. So this is the function f. This is the function f. Now, what will be the inverse of this particular function? What will be the inverse? This inverse will be defined from B to A. And we know B contains 4, 5, 6 and A contains 1, 2, 3. So 4 will be mapping to 1, 5 will be mapping to 2 and 6 will be mapping to 3. Alright, so this is the inverse of a function. I explained it with the help of an arrow diagram. Okay, now we can explain it also with the help of a function. By considering a function itself, we'll explain it. Okay. So consider the function f of x. Consider the function f of x. F of x is equal to x minus 1. Okay, f of x is equal to x minus 1. All right, we have to find out the inverse of this particular function. So inverse is nothing but the reverse process. First of all, you have to understand the process happening here. How will you how do you get f of x? Let f of x be y. Okay, I'm giving it as a name y. F of x be y. Y equal to x minus 1. Y equal to x minus 1. So how do you obtain y? How did you got y? You are subtracting 1 from x. When you subtract 1 from x, you got y, right? Y equal to x minus 1. So what will be that is a process involved in that particular function. All right. Now, what will be the reverse process? Reverse process means how will you find out x from this? Y equal to x minus 1. So how will you find out x from this? You have to take 1 to the other side, right? So it will become y plus 1. Y plus 1 is equal to x. Y plus 1 equal to x. All right. So you have obtained the value of x. So x means you are adding 1 to y. So that means you are actually finding the reverse process, and this particular thing is called as the inverse of that function. Okay, this was our function and this one is known as the inverse of that function, but certain conditions should be satisfied. Okay, actual concept is this, but the thing, if this should be the inverse, then that should satisfy certain conditions that is given in the definition. Okay, we'll just check the definition also. That is, a function f from x to y is invertible if there exists a function g from y to x such that g composition f is equal to ix. Okay, that is I suffix x and this is I suffix y. F composition of g should be equal to iy. What is this ix and iy? Here you can see that f is defined from x to y and G is defined from y to x because it is inverse. So, okay. So, if a function is said to be invertible, then this condition should be satisfied. What is that condition? The composition of that function should be considered. The composition of f should be equal to ix, and similarly, f composition G should be equal to Iy. What is this? Ix is known as the identity function in the set X and y is known as the identity function in the set Y. Alright. So this condition should be satisfied. Now, the second one is a function f from x to y is invertible if and only if it is 1, 1. F is 1, 1 and onto. You can say that a function is invertible or the inverse of a function exists only if that function is bijective. What do you mean by bijective? The function should be 1, 1 and onto, then only the function becomes invertible. Alright, so that is a condition that should be satisfied. Alright, for a function to be the inverse. Alright, so we are moving on to the problems. Okay. First question is, state whether the function f from R to R, defined by f from R to R defined by f of x equal to 3 minus 4x is 3 minus 4x is 1 1 onto 1 1 onto or bijective. 1 1 onto or bijective. You have to justify your answer. Justify your answer. So you are given a function and it is defined from R to R. Okay, you should consider the domain and codomain. It is nothing but the set of real numbers. Alright, f is defined from R to R. And what is f of x? F of x is nothing but 3 minus 4x. What is it? 3 minus 4x. You have to check whether it is 1 1 onto, and if it is both 1 1 and onto, it is bijective, right? So you have to check it. So how will you check it? For a function to be 1 1, okay, first of all, we have to check whether it is 1 1 or not. So what is the condition? That is, if you consider two elements, if f of x1 equal to f of x2, then what is x1 equal to x2? Then we can say that it is 1 1, right? Then we can say that the given function is 1 1. All right, so I'm starting with f of x1 equal to f of x2. What is the function? Function is 3 minus 4x. Function is 3 minus 4x. So in here you have to find out f of x1. So replace this x with x1, right? So this will be 3 minus 4x1. And here you have to find out f of x2. So replace this x with x2. So this will become 3 minus 4x2. All right. This 3 and 3 can be cancelled. So this is minus 4x1 equal to minus 4x2. So here minus 4 and minus 4 is common, so that can be cancelled. So we get x1 equal to x2. Therefore, f is 1 1. Okay, so we have got that f is a 1 1 function. Now what we have to check whether it is onto or not. So we are moving on to the second part, that is nothing but onto. Okay, for that you have to take an element from the codomain R. You have to take an element from the codomain R, right? So I'm taking an element, let it be y. Okay, I'm taking an element y from R. Now, what you have to do? We have to choose y such that f of y equal to f of x. All right, f of x equal to y. So what is f of x? It is nothing but 3 minus 4x is equal to y. Okay, so you are finding out the value of x from this. Now minus 4x is equal to y minus 3. And what is x? X equal to y minus 3 by minus 4. Now what we have to do? If you select an element from, randomly select an element from the codomain, you should get an pre-image, right? You should get a pre-image x in the domain. Then only you can say that the function is onto. That means every element in the codomain should have a pre-image. So if you randomly select an element from the codomain, then also that element should have a pre-image in the domain, right? So I'm randomly y from R. So I should get an x such that it should satisfy f of x equal to y. All right. So I started from f of x equal to y and I found out x equal to y minus 3 by minus 4. Now what I have to do, whether this I have to check whether this x belongs to the domain, that is R. All right. So can you say y minus 3 by minus 4 belongs to R or not? It definitely belongs to R. Right. R means a set of real numbers. It contains all type of numbers. So this will definitely belongs to R because y we have chosen from R. Y is an element that is chosen from R. So y minus 3 divided by minus 4, that number also belongs to R. Definitely we can say that it belongs to R, which means, what does that mean? F is onto also. F is onto. Now what can you say about bijective? It is bijective, right? F is 1, 1 and onto. So here it is 1, 1 and here it is onto. So we can say that it is a bijective function. All right. So you have to write that part also. Here you have given that justify your answer. Because f is 1, 1 and onto, we can say that the given function is bijective. All right. So what can you say about the inverse of that function? The inverse of the function exists or not? Inverse definitely exists because it is a bijective function. Bijective function means it is invertible. The function is invertible. The inverse of the function exists. And vice versa is also true. Okay, that is f is invertible. If a function f is invertible, then we can definitely say that the function will be bijective. If you are given an invertible function, then the function will definitely be bijective. That is, the function will be both 1, 1 as well as onto. All right. So can you say the inverse of this function? Can you say the inverse of the function? How will you find the inverse of this function? I have already explained that if you are given a function, inverse is nothing but the reverse process. Okay, reverse process of the given function. All right. 1 minute. Okay. So it is the reverse process of the process given in the function, right? So we have found out already, we have found out the value of x, right? X is equal to, that is, we put f of x equal to y and we found out that x is equal to y minus 3 by minus 4. All right, y minus 3 by minus 4. This is the inverse. Since the inverse of the function exists, this itself is the inverse of the function. Okay, this itself is the inverse of the function. And okay, this is the inverse of the function. So how will you write the inverse of a function? It is nothing but f inverse. All right, we are finding out the inverse of the function f of x. So we should write f inverse of x, right? And if you are given a function in the variable x, then everything should be in the form of x itself, right? So you can't write it as y minus 3 by 4. This y should be replaced with x. Since it is defined in the variable x, the f inverse of x should be completely in terms of x. All right. So I'm replacing this y with x. So x minus 3 by minus 4. So this one is the inverse of the function. It is not asked in the question, but you should be able to find out the inverse. If a function is bijective, we can automatically find out the inverse of a function. This is one method, okay? You can find out the inverse of a function using compositions also, but this one, I think it will be better for you if you understand the concept. That is nothing but, inverse of a function is nothing but just the reverse process of the function given. All right. So if you are given a function, you find out x and x from that, and then that will be the inverse of the function, provided that f should be 1, 1 and onto. Okay, f should be 1, 1 and onto. That means f should be bijective. Then we can say that it is the inverse. All right. So we are moving on to the next question, okay? So show that the modulus function f from R to R given by f of x equal to mod x is neither 1, 1 nor onto. All right. So we have to, so the domain and codomain is the set of real numbers itself, and they are given the function modeless function. Okay, mod x means modeless function. We have to show that it is not 1, 1 or not onto. It's actually very easy when you do it with the help of a uh, graph. Okay, so this is a graph of a modeless function, right? So if you construct horizontal lines across this, okay, horizontal lines that are parallel to x-axis, these horizontal lines touches the graph in more than 2 points, right? More than 1 point, right? Each horizontal line is touching the graph in 2 points, which means that more than one element has the same image. This one also has the same image. This x has also the same image, which means it is not 1, 1. Okay, for a function to be 1, 1, every element should have a single image. Here you can see that two elements have the same image, two distinct or two different elements have the same image, so it is not 1, 1. Okay, but since this is from the 5 mark question, we have to write the step by step itself. So first of all, we have to prove it is not 1, 1 by using the definition. All right. So I'm taking f of x1 is equal to f of x2. Let f of x1 equal to f of x2. So f of x1 means you have to replace x with x1, right? So modulus of since it is not 1, 1, we can show it by with the help of a counter example. All right, that is easy. We can show it with the help of an counter example. So I'm taking f of 1. Okay, f of 1. So what is f of 1? F of 1 is equal to modulus of 1. That is nothing but 1. Now what about f of minus 1? F of minus 1 is nothing but modulus of minus 1. That is also 1. Right? Here you can see that f of 1 is equal to f of minus 1. Okay. F of 1 is equal to f of minus 1, but 1 not equal to minus 1, right? 1 is not equal to minus 1. Therefore, f is not onto. F is not onto. All right. Similarly, we can find different elements like this, right? If you take f of 2, what is f of 2? Modulus of 2 is equal to 2. What is f of minus 2? F of minus 2 is nothing but modulus of minus 2. That is also 2. Here you are considering two distinct elements, right? Two different elements, and you are getting the same image. Okay, which means it is not 1, 1. Here you can see that f of 2 is equal to f of minus 2, that is equal to 2, but 2 not equal to minus 2. Therefore, f is not 1, 1. Okay, you can take any example like this. Just in order to prove that it is not 1, 1, you just need a counter example. So you can take any number from this and prove it like this. All right. Now we are moving on to the second part, that is we have to show that it is not onto. All right. It is not onto. How will you prove that the given function is not onto? We have to consider an element from the codomain. Okay. First of all, we have to consider an element from the codomain. Then we have to prove that that element does not have a pre-image in R. All right. So here I am going to take an element. Let it be minus 3. Okay, let it be minus 3. Minus 3 definitely belongs to the set of real numbers, right? Real number contains all the numbers, so minus 3 also belongs to the set of real number. Can you find an x such that f of x is equal to minus 3? That is, whether there is any x such that f of x is equal to, the value of f of x is equal to minus 3. Is there any x like that? No, right? Modulus of x means f of x means it is the modulus function. It is the modulus function. Modulus function can never be equal to minus 3. Isn't it? Modulus function means it can take only positive values. Okay, it can take any values, but you will get only positive values. The result will always be positive, right? So it can never be minus 3. It can never be a negative number. Not only minus 3, you can take any negative number, but there does not exist an x such that f of x will be equal to that negative number. All right. So we can say that there does not exist an x such that f of x is equal to minus 3. Therefore, what we can conclude? F is not onto. F is not onto. All right. Okay. So now we are moving on to the second question. Sorry, third question. It is consider f from r plus 2 closed interval 4 infinity given by f of x equal to x square plus 4. Show that f is invertible and you have to find the inverse of f. Okay, so f is defined from r plus. What do you mean by r plus? The set of positive real numbers. R means real numbers. It contains all the type of number. But r plus means the set of positive real number. Okay, set of positive real numbers to what is defined? The codomain is closed interval 4 infinity. What does that mean? The codomain only contains the numbers from 4, including 4 up to infinity. That is, the numbers greater than or equal to 4 is only included in the codomain, which means the numbers less than 4 is not included in the codomain. And the function is nothing but f of x is equal to x square plus 4. F of x is equal to x square plus 4. We have to show that f is invertible. Okay. How will you show that f is invertible? You can use two different methods. So I'll be using the second method. That is by proving f is a bijective function, you will directly get the inverse of that function. All right. We have to show f is invertible. So I'm going to prove that f is 1, 1 and on to thus finding the inverse of the f. All right. So here, first of all, we'll start with 1, 1. Okay, so what is the condition of 1, 1? If you take f of x1 is equal to f of x2, you should get x1 equal to x2, right? So I'm taking x and y, okay? You can take any variable. Here I'm taking x and y. Okay, so I'm putting f of x equal to f of y. You can take f of x1 equal to f of x2. That's your choice. Here I'm taking f of x equal to f of y. So what I have to prove? I have to get that x equal to y. If it is 1, 1, I should get x equal to y. All right. So what is f of x? It is x square plus 4. It is x square plus 4. And what is f of y? You replace x with y, right? That is equal to y square plus 4. All right. Now I'm taking, cancelling this 4 and 4. Okay. That is x square equal to y square. X square equal to y square. This can be written as x square minus y square equal to 0. I took y square to the other side. Okay. X square minus y square equal to 0. And this is in the form of a square minus b square. So we can write it a plus b into a minus b, right? So x square minus y square can be written as x minus y into x plus y, that is equal to 0. All right. If x minus y into x plus y equal to 0, either x minus y can be 0 or x plus y can be 0. Both the cases are possible, right? So from this x minus y equal to 0, by solving x minus y equal to 0, you get that x equal to y. And if x plus y equal to 0, if x plus y equal to 0, you'll get x equal to minus y. X equal to minus y. But is this case possible? X equal to minus y, is that case possible? No. Why? What is the reason? Because you have to check the domain of the function. What is the domain of the function? It is defined from r plus 2 4 infinity. Right? This is the domain of the function. It is a set of positive real numbers only. So can x take the value minus y? X cannot take any negative values, right? X cannot take any negative values because it only contains the positive real number. So x cannot take the value minus y. So only this case is possible. That is x equal to y. This case is only possible. So we started from f of x equal to f of y and we obtained that x is equal to y. From this you got that f is 1, 1. Okay. So it is clearly a 1, 1 function. Now what you have to do? I have to find out the whether it is onto or not. Okay. It will definitely be onto because they have given in the question that show that f is invertible. Okay, if f is invertible, it is definitely a bijective function. So it will definitely be onto. So how will you prove it is an onto function? You have to take an element from the codomain. You have to randomly take an element from the codomain. Sorry, this is not the codomain. Our codomain is y belongs to closed interval 4 infinity. So I'm taking an element from the codomain y that belongs to 4 infinity. All right, such that f of x equal to y. F of x equal to y. And what is f of x? Which is nothing but x square plus 4. X square plus 4 is equal to y. All right, x square plus 4 is equal to y. So what is x square from this? X square is equal to nothing but y minus 4. Isn't it? X square is equal to nothing but y minus 4. Now what can you say about this y minus 4? Can this be negative number? Y minus 4 can be a negative number. No, right? It is always greater than or equal to 0. Y minus 4 is always greater than or equal to 0. What is the reason? Because y cannot take any numbers which are less than 4. If you put the numbers less than 4 here, then you will get negative number, right? If you put 4, y can take the value 4, right? Y starts with 4. Y can take the value 4. So 4 minus 4 is equal to 0, which means the value of x square starts with 0 itself. Okay, no negative numbers is included. If you put y equal to 3, then 3 minus 4 will become minus 1. But y cannot take the value 3 because the codomain is restricted only from 4 to infinity. That means the negative numbers which are less than 4 is not included. So 3 is also not included. So this one cannot take negative values. It is always greater than or equal to 0, which means we shall only consider the positive root of y minus 4. So x can be plus or minus root of y minus 4, but it is always greater than or equal to 0, means always positive, because y is restricted to the interval closed interval 4 infinity. All right, so x equal to, we should only consider the positive root of y minus 4. X equal to positive root of y minus 4. All right, so can you say that this belongs to the set of R plus? It definitely belongs to R plus, which is the set of positive numbers only. Here you can see that y cannot take the numbers less than 4. Then only the value inside this become negative, right? Then only the value inside this become negative. So we can clearly say that x equal to root of y minus 4 belongs to the set of positive real number. Okay, set of positive real number. Therefore, we can conclude that f is onto. What we can conclude? F is onto. Now, how will you write the inverse since it is 1, 1 and onto, which means it is bijective. If a function is bijective, it is definitely invertible. So, you have to write that also. Here, f is 1, 1 and onto. Okay, how will you write this? F is 1, 1 and onto. 1, 1 and onto, which implies it is bijective. Okay, f is bijective. F is bijective implies f is invertible. F is invertible. All right. F is bijective implies f is invertible. Now, the next part is find the inverse of f. How will you find the inverse of f? It is just the reverse process, and we have already found it as x equal to root of y minus 4, right? We have already got the value of x, that is equal to root of y minus 4. That itself is the inverse of that function. All right. So how will you write this? We have to write this in terms of inverse, f inverse of x. Okay, here you have to always check that this one will be in terms of y, but you are writing f inverse of x, so the variable is in x, so you have to change the y as x. Okay, you have to express everything in terms of x if the variable inside is x. All right, so the function will be root of x minus 4. Instead of y, I wrote x, root of x minus 4. So this one is the inverse of the given function, that is x square plus 4. All right. So moving on to the next question. Here, show that the signum function f from R to R defined by f of x equal to, it is given as a Dirichlet function. Okay. That is f of x is equal to modulus of x by x when x not equal to 0 and 0 when x equal to 0. All right. So this one, first of all, you should understand the function. Okay, it is the signum function, and we have to show that it is neither 1, 1 nor onto. Okay, we have to show that it is neither 1, 1 nor onto. All right. So first of all, we can rewrite this function. Okay, that is we are going to understand what this function is. All right. So here they have given that when x not equal to 0, the function is defined as mod x by x. X not equal to 0 means x can be less than 0 and x can be greater than 0. There itself there are two cases, right? X can be less than 0. First case, x can be greater than 0 also. X not equal to 0 means. All right. And the next case is x equal to 0. That is, the function will take the value 0 itself. When x is 0, the function is value of function is also 0. Now we have to find out what happens if x is less than 0. Okay, if x is less than 0, how can you write x? X less than 0 means x is a negative number. So how will you write a negative number? So I can write it as minus x, right? So if x less than 0, this is the definition of the function, modulus of x by x. So modulus of minus x by minus x. All right, modulus of minus x is nothing but x. It takes only positive values, right? So x by minus x. What is x by minus x? It is minus 1. All right. Now, what is x greater than 0? When x greater than 0, also the function is defined as mod x by x. So if x greater than 0 means it is a positive number, so we can write it as x itself. Modulus of x by x, that is equal to modulus of x means x. X by x is equal to 1. Okay, so x less than 0 means the function will take value minus 1, and if x greater than 0 is means the value of the function is 1, and if x equal to 0, the value of the function is 0. Okay, I hope you have understood the given function, that is signum function, which means uh, if uh, if x is less than 0, which means x is a negative number, then the function maps it to minus 1. If x is greater than 0, which means x is a positive number, then the function maps it to 1. Okay, and if x equal to 0, the function maps 0 to 0 itself. All right, so that is our function. Now we have to prove it is not 1, 1, not on 2. So if you have to prove that it is not 1, 1 and on 2, you just find out a counter example. All right, you just find out a counter example. So how will you find out a counter example? Let consider f of 3. All right, f of 3. What is f of 3? What is f of 3? 3 means greater than 0. So what is greater than, when greater than 0, what is the value of the function? Okay, 3 belongs to this part, right? X greater than 0. Isn't it? 3 is a positive number. So what will be the value of the function? 1. F of 3 is equal to 1. Now I'm taking f of 6, okay? F of 6. What will be the value of the function? That is also greater than 0. So the value of the function will be again 1. What is f of 8? What is f of 8? That is also 1. Similarly, you can find numerous number. If you take any positive value, the function maps it to 1 itself. So you have so many different elements that has the same image 1. So can you say that it is 1, 1? No, it is not 1, 1. Here you can write like this. F of 3 equal to f of 6. But 3 not equal to 6. 3 is not equal to 6. They are different elements, but their images are same. So you can say that f is not 1, 1. F is not 1, 1. All right. Now what you have to do, you have to prove that it is not on 2. Similarly, you prove it with a counter example. Consider a counter example. That is, if I take minus 3. Okay, it is defined from set of R to R, isn't it? So R contains all the numbers, set of real numbers. It contains all type of numbers. So negative numbers is also included. Okay, if I take minus 3 belongs to R, minus 3 belongs to R, can you find an x from the domain R? Can you find an x from the domains R such that f of x is equal to minus 3? F of x equal to minus 3? No, isn't it? Because f of x are only getting the values minus 1, 1 and 0. Isn't it? So every element is either mapped to minus 1, 1 or 0. No other values are getting mapped, isn't it? So minus 3 doesn't have a pre-image. F of x can never be equal to minus 3 in this particular function. So there does not exist an x such that f of x is equal to f of x is equal to minus 3. Similarly, you can find numerous numbers. If you take f of x equal to 6, okay, if you take 6 belongs to R, can you find an x from R such that f of x equal to 6? So f of x can never be equal to 6. Alright, so you can find different numbers from R that doesn't have a pre-image in the domain R. Alright, therefore we can conclude that f is not onto. F is not onto. Okay. This can be explained with the help of an arrow diagram also. Okay, let this be R, okay. It is not a finite set, so you can't exactly do it like this, but I'm doing it to make it more clear. Okay, so here there will be infinite numbers, okay, etc. Let it be -2, -1, -3, then 0, then there will be fractions, every numbers will be there, okay. 1, 2, 3, in between the decimal numbers, everything is included, okay. I'm putting etc. like this. And then here also there will be -3, -2, -1, 0, then the numbers in between, then 1, 2, 3, etc. All right. So here you can see that if x is less than 0, x less than 0 means all these numbers, isn't it? All these numbers, x less than 0 means. So if I take x equal to -3, -3 will maps to -1. -2 will also map to -1. -1 also maps to -1, and the numbers in between these, okay, and numbers in between this all map to -1. Similarly, you can see that all the positive numbers, the numbers in between all maps to 1. All maps to 1, isn't it? All the positive number is getting mapped to 1, and 0 is mapping to 0 is mapping to 0. 0 is mapping to 0. Here you can see that all these elements doesn't have a pre-image, right? So we can say that it is not onto. All right, it is not an onto function. And so here you can see that many elements have a same image. Many elements, all these elements have the same image, so it is not 1 also. All right, I hope it is clear to you all. Now we are moving on to the next part, next question. All right, let f from n to n is defined by f of n is equal to n plus 1 by 2 if n is odd, and n by 2 if n is even. State whether f is bijective and justify your answer. Okay, so what you have to do, we have to check whether the given function is bijective or not. Then you have to justify your answer also. So first of all, you should understand the domain and codomain. It is a set of natural number. So set of natural numbers means nothing but it is 1, 2, etc. up to infinity. Okay, it is 1, 2, etc. up to infinity. It does not contain the number 0, isn't it? So it is defined from the set of natural number to natural number, and the function is defined in this way, that is, if n is an odd number, it is n plus 1 by 2, and if n is an even number, it is n by 2. So here I'm taking to prove check whether it is 1 1 or not. Okay, I'm taking the case that is let n1 be odd. Okay, let n1 be a number, let n1 be an odd number, and n2 be an even number. Or you can also take um, n1 as okay, you can also take n1 as an even number and n2 as an odd number. Okay, it's your choice. So here I'm taking n1 as an odd number and n2 as an even number. So let n1 be 3 and n2 be 4. All right, so what is f of 3? F of 3, 3 is an odd number, so odd number means the function is n plus 1 by 2. So n plus 1 by 2, isn't it? So in place of n you put 3. 3 plus 1 by 2, that is equal to 4 by 2 equal to 2. All right, now what is f of 4? F of 4, 4 means an even number. So if it is an even number, it is n by 2. The function is n by 2. The function is n by 2. So what is n? It is 4. So 4 by 2. 4 by 2 is equal to 2. Now what you have got? Here f of 3 equal to f of 4, isn't it? both the values are 2. F of 3 equal to F of 4. But 3 is not equal to 4. 3 and 4 are different elements. So what can you conclude from this? F is not 1, 1. F is not 1, 1. Alright, F is not a 1, 1 function. Okay, now what you have to do? We have to prove that it is not, no. We have to check whether it is onto or not. Alright, so the second part is whether it is onto or not. Okay. So here there will be two cases when one is when n is an odd number and the other is when n is an even number. So first of all, if you take n as an odd number, so take an element n from n. Okay, n from n such that f of n is equal to y. Okay, f of n is equal to y. Then what will be the function? It is an odd function, right? Odd function means n plus 1 by 2 is equal to y. N plus 1 by 2 equal to y. Alright. So n plus 1 by 2 means n plus 1 is equal to 2y. So what is the value of n from this? N is equal to 2y minus 1. Okay, n is equal to 2y minus 1. So what can you say from this? What can you say from this? I'm sorry. First case is n is odd, and we are taking f of n such that f of n is equal to y. Not n belongs to n. F of n is equal to y, and then you know that it is an odd function. So the function will be n plus 1 by 2 is equal to y. So n plus 1 will be equal to 2y, and n will be equal to 2y minus 1. So what can you say about this 2y minus 1? Since we have taken y from n, isn't it? Y from n. Okay, we have taken y from n, set of natural number. So 2 into a natural number minus 1 means it is again a natural number, right? Isn't it? 2 into a natural number will definitely be a natural number. If you subtract 1 from that also, it will definitely be a natural number. So we can say that clearly this n belongs to the set of natural number. So what can you conclude from this? This n belongs to set of natural number. That means n belongs to the domain. So we can say that f is onto when n is odd. F is onto when n is odd. Now consider the case n is even. What about when n is even? N is even, then take y element of n. Okay, I'm taking y from the codomain, and such that f of n is equal to y. And what is f of n? When n is even, it is nothing but n by 2. N by 2 equal to y. So n is equal to 2y. Clearly, this belongs to the set of natural number. Since y is a natural number, multiplied by 2 is also a natural number. So we can say that f is onto when n is even. Okay, f is onto when n is odd, and f is onto when n is even. So both the cases it is satisfied. So we can say that the function is onto. But here the question is state whether f is bijective. Since it is not a 1-1 function, it is not a bijective function. Okay, it is just an onto function. All right. Now we are moving on to the next question. Let f from n to y. N means a set of natural number, and y is another set. Be a function defined as f of x is equal to 4x plus 3, where y equal to, y means the set of all y element of n such that y is equal to 4x plus 3 for some for some x belongs to n, show that f is invertible. Show that f is invertible. Find the inverse of f. Find the inverse of f. Okay, the function is defined from the set of natural numbers to y. Okay, what is y? That is also defined here. What is y? Y is nothing but the collection of y element of n. Y is definitely a member of the natural number itself, but it has another condition, that is y is equal to 4x plus 3. It is a set of natural number, but all natural numbers are not included. Only those numbers which are in the form of 4x plus 3. What do you mean by 4x plus 3? It is a 3 added to multiples of 4. So that contains the elements in such a way that it will be of the form 3 added to the multiples of 4. Alright, that is 4x plus 3. And this x belongs to the set of natural numbers. Okay, x belongs to n means x belongs to the set of natural number. We have to show that f is an invertible function. We have to show that f is an invertible function, and we should also find out the inverse of the function f. All right, this one is an important question, especially in the 5-mark part. All right, so we have to we'll find the inverse of this function in the two methods. Okay, one with the we have already done it, right? That is proving f is bijective. We can find out the inverse, and the other one is by composition also. All right. So the first method is the method that we have already followed till now. That is, first of all, you should consider it 1-1. Consider the part 1-1, right? Okay. So f of x is equal to f of y, isn't it? Then we have to show that x equal to y, isn't it? So what is f of x? F of x is 4x plus 3. And what is f of y? F of y is nothing but 4y plus 3. F of x is 4x plus 3 and f of y is 4y plus 3. So this means 4x equal to 4y. 3 gets cancelled, isn't it? Here 4 gets cancelled. So x is equal to y. X equal to y. So we started from f of x equal to y and we obtained x equal to y. From this, what can you conclude? You can conclude that f is 1-1. F is 1-1 function. Okay, now we are going to check the onto part. All right, we are going to check the onto part. So how will you check the onto part? You have to consider an element from this set, isn't it? The codomain. Then you should get a pre-image in the domain. You should get a pre-image in the domain. So y belongs to, let y belongs to y, such that f of x is equal to y. Now what is f of x? F of x is nothing but 4x plus 3. 4x plus 3 is equal to y. So 4x is equal to y minus 3. 3 I took to the right side. And what about x? The value of x is y minus 3 by 4. Isn't it? Y minus 3 by 4. So can you say that y minus 3 by 4 belongs to the set of natural number? Definitely it belongs to the set of natural number. Why is it so? Because all the elements y, okay, all the elements y are in the form of 3 added to the multiple of 4, isn't it? Here you can see that all the y are in the form of 4x plus 3, which means this y, okay, which means this y is also in the form of 4x plus 3. So how can you rewrite this? That is, if I put 4x plus 3 in place of y, okay, that is y minus, consider y minus 3 by 4. If I put 4x plus 3, then minus 3 by 4. That means 4x by 4. That is equal to x. And this x is definitely belongs to, here you can see that x definitely belongs to the set of natural number. So we can say that this belongs to the set of natural number. Okay, so f is onto also. F is 1-1 and onto, which implies that it is a bijective function, isn't it? 1-1 and onto means it is a bijective function. If a function is bijective, then definitely it is invertible. And what will be the inverse? Inverse is nothing but this one. Okay, this one is the inverse of the function. So how will you write it as in the form of inverse? How will you write this one in the form of inverse? F inverse of x equal to, replace this y with x minus 3 by 4. F inverse of x is equal to x minus 3 by 4. All right. Now we are moving on to the second method. Okay. That is by using composition, we can prove this. By using composition of function, we can prove this. That is, I'm going to define a function. Sorry, this is already defined a function, that is f is defined from n to y. All right. And in the previous case, that is, we found out the value of x, isn't it? That is, you put the first step is you select an element y. You select an element from y, such that f of x equal to y. Then here you know f of x is nothing but 4x plus 3. 4x plus 3 equal to 5, y. And by solving this, you get x equal to y minus 3 by 4. Isn't it? So you have got the value of x. Now we have to check whether its inverse exists or not by using composition, right? So take this as a new function. Okay. Take this x as a new function. Let that function be g. So I am naming it as g. G will be defined from y to n, isn't it? G will be defined from y to n. All right, y to n. Now, such that g of g of y or g of y be, let g of y be, how will you define y minus 3 by 4? Let the function g of y be y minus 3 by 4. Okay, so I am giving this function as, taking that function as g. Y minus 3 by 4. Now you have to check whether this is the inverse or not. So by using composition. Okay. That is, first you find out f composition g. If you get in and g composition f is equal to iy, then we can say that it is the inverse. G is the inverse of f. All right. So that is the condition. So f composition of g is equal to, how will you find out? F of g of x. We start with the second function, f of g of x. And what is g of x? F is, put f like that. What is g of x? G of x is nothing but y minus 3 by 4. Isn't it? Sorry. G of x will be x minus 3 by 4. Isn't it? So, here we have already defined in terms of y. So, I am replacing this variable with y. Okay. We have defined the function g as y in terms of y, right? So, I am replacing this with y itself. So, f composition of g of y. F of g, f composition g is f of g of y. That is f of, what is g of y? It is y minus 3 by 4. F of y minus 3 by 4. All right. So, what is f? F is 4x plus 3. F is 4x plus 3. But can you put it as x? No. In place of x, it is y minus 3 by 4. So, replace x with y minus 3 by 4. So, this will become 4x. In place of x, it will be y minus 3 by 4. 4 into x is 4 into y minus 3 by 4 plus 3. Okay. So, this one gets cancelled. Isn't it? Y minus 3 plus 3. Minus 3 plus 3 is 0. That is equal to y. So F composition G is equal to, F composition G is equal to Y. That is equal to IY. Isn't it? It is the identity function in Y. Okay, it is the identity function in the set Y. All right. Now you have to find out, G composition F. G composition F. That is equal to G of F of X. Isn't it? G of F of X, because the function f is defined in terms of x. So g of f of x. All right. So g of 4x plus 3. F of x is nothing but 4x plus 3. That is equal to g of 4x plus 3 means the g is y minus 3 by 4. Here in place of y, you put 4x plus 3. That is 4x plus 3 minus 3 by 4. That is equal to 4x by 4. That is equal to x. That is equal to I, identity function in N. All right. Okay. So it is the identity function in N, isn't it? So we can conclude that G composition F is equal to IN and F composition G is equal to IY. F composition G is equal to IY. So we can say that G is the inverse of F. G is the inverse of f. What is G? G of y is equal to y minus 3 by 4 is the inverse of f. Alright, so these are the two methods to find out the inverse of a given function. Alright, now we are moving on to the last question. Show that f from n to n, given by f of x equal to, f of x is equal to x plus 1 if x is odd, x plus 1 if x is odd, and x minus 1 if x is even, and x minus 1 if x is even, is both 1 1 and onto, is both 1 1 and onto. So f is defined from the set of natural numbers to set of natural number, and the function is, when x is odd, the function is x plus 1, and if the x is an even number, the function is x minus 1. All right, that is the function given, and we have to show that it is both 1 1 and onto. So it is 1 1 and onto. We have to prove that it is it satisfies the conditions of 1 1 and onto, isn't it? So first of all, if you consider 1 1, they have given that it is 1 1, so we have to prove it in general form, isn't it? So in the case of 1 1 itself, there are three cases, isn't it? That is, if we randomly choose two numbers from this, you can see that if the numbers if both the numbers are odd, then the function will be like this. If both the numbers are even, then both the function will be like this. But there is another case also, isn't it? One number can be an odd and the other number can be an even. So we have to consider three cases to check whether the function is 1 1 or not, isn't it? So first case is case 1. Consider the case 1. That is, if x1 and x2, okay, x1 and x2 are odd, x1 and x2, both the numbers are odd. Then if I take f of x1 equal to f of x2, what can you say about the function? Both are odd, isn't it? So both has the function, function takes the function x plus 1. So replace x with x1. x1 plus 1 equal to x2 plus 1. You can cancel this 1, isn't it? So x1 equals to x1 equal to x2. x1 equal to x2. So when x1 and x2 are odd, we started from f of x1 equal to f of x2. Then we obtained x1 equal to x2. It is satisfied. The condition of 1 1 is satisfied in that case. Now, the second case is if x1 and x2 are even. x1 and x2 are even. Now what happens? F of x1 equal to f of x2 implies it is an even function, so it takes the value x minus 1, that is x1 minus 1, that is equal to x2 minus 1, which implies x1 equal to x2, isn't it? So in that case also, the condition of 1 1 function is satisfied. Okay, now I'm going to consider a third case. All right, the third case is one can be an odd number and the other can be an even number. Let x1 be odd and x2 be even. One can be an odd number and other can be an even number, right? So here you can see that if you consider f of x1 equal to f of x2, since x1 is odd, it takes the function x plus 1. So x1 plus 1, that is equal to, and since x2 is even, it takes the function x minus 1. So it will become x2 minus 1, isn't it? So I'm taking this x2 here. x1 minus x2 is equal to minus 1 minus 1 minus 1, that is equal to minus 2. Here you can take x1 as, an even. Okay, let x1 be an even number and then x2 be an odd number. Okay, x2 be an odd number. Okay, so what happens if then what happens to f of x1? It is an even, so this will be x1 minus 1, that is equal to, here x2 is odd, right? So it will be x2 minus 1. x1 minus 1 is equal to x2. So x1 minus x2 is equal to, sorry, x2 is an odd number, so it will be x1 x2 plus 1, isn't it? So 1 plus 1 is equal to 2. So x1 minus x2 is equal to 2. Okay, difference of an odd number and even number can never be 2. Difference of an odd number and an even number can never be 2. In the previous case, it was minus 2. So that is also not possible. So the difference of an odd number and even number can never be 2 or minus 2, isn't it? So what can you say from this? That the case 3 is not possible. Okay, so since x1 minus x2 can never be 2, case 3 is not possible. And in case 1 and case 2, we got that the function is 1, 1. Since this is not possible, we shouldn't consider this one, which means that the function is 1, 1. Okay, in both the previous cases, we got that function is 1, 1. So we can conclude that f is a 1, 1 function. So you write here, this case is not possible because the difference of two number can never be 2. Two number can no difference of an even number and an odd number can never be 2. So this case is not possible. All right. So we can conclude that f is 1, 1 function. All right. Now we are moving on to the onto part. We are moving on to the onto part. Okay. I'm choosing a random element y from n. All right. Such that f of x equal to y. And if x is odd, there will be two cases, isn't it? If x is odd, what is f of x? F of x is x plus 1. X plus 1 equal to y. And from this, what can you say about x? X equal to y minus 1. X equal to y minus 1. Since y is a natural number, y minus 1 is also a natural number. So x belongs to the set of natural number. Therefore, f is onto. Therefore, f is onto. All right. Now the second part, y belongs to the set of natural number such that f of x equal to y. And here x is even. Okay, consider x an even number. So what will be f of x? Even number means it is x minus 1, isn't it? So x minus 1 equal to y. So x equal to y plus 1. And since y is a natural number, 1 added to the natural number y is also a natural number. So we can say that x is a natural number. X is a natural number. So f is onto in that case also. When x is an even number also, f is onto. When x is an odd number, then also f is onto. So we can conclude that the given function is both 1, 1 and onto. All right. So that's all for this section. So we have discussed the most of the important questions that can be asked in the 5-mark question session. All right. I hope this was useful to you all, and thank you.